Next question. Question number 5. You're given a wavelength of transmission. Wavelength of transmission is 2 centimeters and relative speed is 300 meters per second. Find frequency shift in kilohertz and relative speed in knots. So here you're given a wavelength of 2 centimeter transmission wavelength, and you're given the relative speed is 300 meters per second. You're asked to find out frequency shift in kilohertz. The second part is relative speed in knots. It is a simple conversion from 300 meters per second to knots, nothing much here. The first part is asking you to find out the frequency shift. So the equation is relative velocity by speed of light is equal to frequency shift divided by frequency of transmission. And here it is given wavelength. So remember the other equation? Relative velocity is equal to wavelength of transmission into frequency shift. It's very, very easy if you can use this equation out. So frequency shift is equal to relative velocity divided by wavelength of transmission. Relative velocity is given in 300 meters per second. And therefore the wavelength also should be in meters, 2 centimeters, 2 10 to the power minus 2 meters. And therefore what is the answer? It's 1.5 into 10 raised to 4.
1.5 into 10 raised to 10. What that is? 15 gigahertz.
It's the frequency. Right, so you're finding it frequency first and then finding the FT. I just use the second equation straight, where that is much more easier here because wavelength is given, right? And you will get 15 kilohertz as the answer. And the second part of it is very easy. You just asked to convert the relative speed from 300 meters per second. You have to convert that to knots. So 300 meters has to be converted to nautical miles first by dividing by 1.852 knots. And seconds you convert to hours by multiplying with 3600. So it's going to be almost double of this, close to 600. Let's find out. 300 into 3600.
Kilohertz. Oh, yes.
583 knots, and the frequency shift is 15 kilohertz. Right? Alright. Next one. They're given a transmission wavelength of 3.41 centimeters. They're given a relative speed in knots as 450 knots. You are asked to find out frequency shift in kilohertz, and this time a relative speed in meters per second. So in wavelength is given, you can see the second equation is much more easier because you don't have to find out the frequency at all. That will prove to be time saving for you. So here you're asked to find out the frequency shift again. Frequency shift is equal to relative velocity divided by wavelength. Relative velocity in knots is what is given. So make sure you convert that into meters per second first. So first when you convert to meters per second, 1 nautical mile is 1852 meters, right? And it's
meters per hour and divided by 3600.
This is in seconds, right? This is
231.5.
Alright, so that is the second part of it. This is asking you to find out relative speed in meters per second. So you're converting 450 knots to meters per second. How much is it?
231.5 meters per
231.5,
second.
right? So substituting, this is exactly how it is done. We're converting that to meters first and then dividing by second, you will get 231.5. Now putting that in meters per second here straight, so it's 231.5 meters per second divided by the wavelength is 3.41 centimeters. Converting that to meters, it is 10 raised to minus 2 meters. What is the answer? (231.5) divided by 3.41. So it's almost 6.7 kilohertz. 6.7, 6.79 kilohertz. So just change this 10 raised to 3, 10 raised to 2, 10 raised to 3, and I have put that decimal point a digit before. That's 6.7 kilohertz, and the second part is 231.5 meters per second. Yes. Next question, you're given a wavelength again, which is 2.26 centimeters. And you're given a relative speed in knots as 340 knots. You're asked to find out frequency shift in kilohertz and your relative speed in meters per second. Exactly the same type of question. There's nothing different. It will be easier if you can find out relative speed in meter per second first, because and then you can use that for the first part. So this is the second part here, relative speed in meters per second. Your relative speed is given in knots here, which is 314 knots. Knots is simply nautical miles per hour. So you convert that to meters per second. First you have to convert nautical miles to meters, which is by multiplying with 1852, it becomes meter per hour. You have to convert to seconds, which is by multiplying with 3600.
161.53 meters per second.
That's 161.53 meters per second. And now using that, you can find out the answers to the first question. Frequency shift is equal to relative velocity divided by wavelength. Relative velocity in meters per second is 161.53 meters per second divided by wavelength is 2.26. Now that is in centimeters. Converting that to meters, that is 10 raised to minus 2 meters. How much is that?
7147.60 hertz. That is 7.15 kilohertz.
Kilohertz is right. 7.15 kilohertz. Let's look at another question where the wavelength is given as 23 centimeters. Wavelength and frequency shift is 2.3 kilohertz. We are asked to find out the relative speed in meter per second and the relative speed in knots. So basically you have to find out the relative speed here and then just swap the units. That's all. Right. Again, since the velocity, the wavelength is given, you see that if the wavelength is given, this equation is much easier if you have tried using this, because you don't have to find the frequency at all. Unless they ask for observed frequency and stuff, you don't necessarily need this at all. So frequency shift is equal to relative velocity divided by wavelength, and that is relative velocity is something which you have to find out. Frequency shift is given as 2.3. And remember, it is in kilohertz, so you have to convert to hertz by multiplying with 10 raised to 3.
10 raised to 3.
You're asked to find out relative velocity divided by wavelength is 23, and that's in centimeters. You have to convert that to meters. And now the relative velocity will be in meters per second, because this hertz is nothing but 1 by second. So relative velocity 529 meters per second. And if I convert this to knots, how will I convert that? So to convert meters to nautical miles, I have to divide by 1852, and seconds to hours I have to multiply by 36,000 here because it's division by 36,000. Yeah.
1028 knots.
That's going to be roughly double, which is the answer to the second part, which is 1028 knots. Right. All right, and the last question here is, we're given a wavelength of 3.41 centimeters, 3.41 centimeters, and frequency shift of 7 kilohertz. Of 7 kilohertz. Again, you have to find out the relative speeds in meters per second and in knots. Easy. The first one is to find out the frequency shift in meters per second. The equation is relative velocity in meters per second by wavelength in meters. Therefore, relative velocity is equal to frequency shift is 7 kilohertz, that is 7 to 10 raised to 3 hertz, multiplied with the wavelength is given in centimeters. We convert that to meters by multiplying with 10 raised to minus 2. So how much is the relative velocity?
.7 meters per second.
238.7 meters per second. Now let's convert that to knots. 238.7.
464 knots.
Yeah, it's almost a double. 1852 into 36,000. So it's 4. How much?
64
464
knots.
This is. Now these questions are as such not difficult since you've seen plenty of them now. We should be able to do it. The common areas of error here is units. If you're not very careful with the unit, then you probably will go wrong. Right? Yes. That is it about your Doppler system. We will study about Doppler radars, its working, and few more other questions based on finding the velocity, ground speed and stuff later when we talk about primary radars. Because the Doppler radar is an example for a continuous wave primary radar. So we'll talk about two of that. One is the airborne weather radar and the other is the Doppler radar. So we'll talk about this once we talk about radar later.